We're still working in 2.5. I want to continue with some examples that'll help you out. This says, where does f of x equals x squared minus 10x plus 3 and g of x equal to x cubed minus 12x have horizontal tangent lines? Well, key information you want to remember this is, if you have horizontal tangent lines, this means, remember, when you see slope of tangent lines, those are going to be your f prime of x. That means you need to do derivative. And horizontal tangent lines is where that slope is equal to 0. And so we're going to have to first kind of do this in two parts. I'm going to take your f equation and I'm going to take the derivative. So this would be equal to 2x minus 10. And I'm just going to set that equal to 0 to find out where the horizontal tangent lines would be and solve it out. So I get 2x equal to 10. And then I get x to be 5. So at the value of 5, f of x would have a horizontal tangent line. Now let's look at g of x, and I'm going to go ahead and take the derivative of it. That would be 3x squared minus 12, and I'm just going to set that equal to 0. I'm going to solve it out. This gives me 3x squared equal to 12, and then divide both sides by 3. That gives me x squared equal to 4. Not done yet. Square root. So x is equal to plus or minus 2. Don't forget that plus or minus. So these are the values of the horizontal tangent lines. Again, it's all going to be about your keywords. Let's look at the next one. This is at cost c of x equal to the square root of x dollars to produce x golf balls. What is the marginal production cost to make a golf ball? What is the marginal production cost when x is equal to 25 and x is equal to 100? Include your units. And so the key that you want to remember this, when you see this word marginal, this is going to mean that you're working with derivative. So it says the cost c of x is equal to the square root of x dollars to produce x golf balls. And so the fact that we want to do marginal cost, I'm going to say c prime of x is equal to, now I'm going to go ahead and do my algebra first. This would be x to the 1/2. So when you go do the derivative, that would be 1/2 x to the negative 1/2. Now we're going to have to evaluate something with this. So I'm going to go ahead and clean this up. This would be 1/2. And then instead of x to the negative 1/2 being on top or out to the side, I'm going to move it to the bottom and put my square root of x. So this is the marginal cost to make a golf ball. What is the marginal cost when x is 25? So I'm just plug it in. 1 over 2 square roots of 25 gives me 1 over 2 times 5, so 1/10. And so that is the marginal cost to produce 25 golf balls. What about when x is 100? That would be 1 over 2 times the square root of 100. So 1 over 2 times 10, so 1 over 20. And it says include units. So this is golf balls per dollar. And so this is really interesting. The fact that we're producing more and the cost is going down, which makes sense. The more in bulk that we're producing. So again, marginal means to do derivative. So make sure you do your derivative correctly. And then from there, we were just plugging into that value. Last example. An arrow shot straight up from the ground level with an initial velocity of 128 feet per second will be at a height of h of x equals negative 16x squared plus 128x feet at x seconds. A, determine the velocity of the arrow when x is equal to 0, 1, and 2 seconds. B, what is the velocity of the arrow at any time x? At what time x will the velocity of the arrow be 0? What is the greatest height the arrow reaches? How long will the arrow be aloft? F, use the answer for velocity in part B to determine the acceleration at any given time. All right, so let's start over and let's just see what we got to start with here. So we've got this function h of x equal to negative 16x squared plus 128x. And that's our equation. So if you see initial things like velocity, acceleration, you should be thinking derivative. And so if we take the derivative of h of x, h prime of x, that's going to be equal to my velocity function. So I'm just going to apply my power rule here. This would give me a negative 32x plus 128. And I know I'm getting ahead of the game here, but let's go ahead and talk about acceleration. that would be the second derivative of your position function, or the first derivative of your velocity function. Your acceleration function would be equal to the derivative of this, which is just negative 32. And so already we can see what is the velocity of the arrow v of x at any given time of x. It would just be negative 32x plus 128. And then it says, use your answer for velocity to determine the acceleration at any time. And so our part F, just by noting our keywords, the acceleration would be negative 32. And so those keywords are going to be really helpful in what functions or what instructions direction you need to take this. Now I know I've gotten out a little bit of order here, so let's just kind of go backwards here. Determine the velocity of the arrow when x equals 0, 1, and 2 seconds. So we're just going to plug into this equation we have. So our velocity at 0 would be equal to negative 32 times 0 plus 128, or 128, which makes sense because we had an initial velocity of 128. And then if we look at the velocity after 1 second, then that would be negative 32 times 1 plus 128. And so just a simple calculation will tell us that the velocity after 1 second is 96 feet per second. And then the velocity after 2 seconds would be negative 32 times 2 plus 128. And so then that would give me a value of 64 feet per second. And this makes sense because your arrow is being shot straight up. It has that initial velocity of 128, but with gravity pulling down on it, its speed is going down, or its velocity is going down. So now we've got part A, determine the initial velocity of the arrow when it's 0, 1, 2 seconds. And so we've got those values here. We've already done part B. Part C says at what time x will the velocity of the arrow be 0? So we want to know when is our velocity, which is negative 32x plus 128, 0. And so it's just a matter of solving that out. So I'm going to subtract negative 128. That gives me negative 32x equal to negative 128. Divide by negative 32. And so then x is equal to, again, just grabbing your scientific calculator as you go, 128 divided by 32 gives us a value of 4. So after 4 seconds, our velocity is going to be 0. What is the greatest height the arrow reaches? So we've got A, B, and C here. So now we're on part D. For D and E, we're going to have to veer away a little bit from our derivatives, and we're talking about heights, or how long it will be aloft. And so we're just going back into our position function. And so I'm going to scroll down here. Let's just remember what that was. H of x was equal to negative 16t squared. Oh, didn't mean to show variables on you there. Plus 128x. Now this is going to go back to your algebra days. If we have our function, we want to know what's the highest it goes. That's right here. That is the vertex of your parabola. Remember, that is negative b over 2a, f of negative b over 2a. And so a is equal to negative 16, b is equal to 128. So I'm going to say x is equal to negative b, which is 128, over 2 times a, negative 16. And we're just going to calculate that out. That gives me negative 128 over negative 32, which is just 4. And so that tells me after 4 seconds, I'm reaching that height, which we saw here in this last calculation. But I want the height of it, so now I'm going to take that 4 and plug it into my position function, or my height function. So that would be h of 4 is equal to negative 16 times 4 squared plus 128 times 4. You're going to grab your scientific calculator or the calculator that's on your online homework and type that in. And that gives us a value of 256. So how high did it go? That height right there is 256 feet. Now the last part, again, we're going to have to use our algebra for, is how long will the arrow be aloft? Well, we can see that Here we've already found out to be at 4 seconds or a height of 256 feet. And so from here to here is the amount of time that the arrow will be aloft. And so that's a matter of solving your quadratic for your intercepts. So we're going to come down here. We're going to take our quadratic, h of x equal to negative 16x squared plus 128x. We're going to set it equal to 0 and find those intercepts. Now I am going to go ahead and factor out a negative 16x out of the function. This leaves me with an x minus 8 equal to 0. So that's nice. It's going to factor for us. So now negative 16x could be 0 or x minus 8 could be 0. Divide both sides. So I get it x equals 0, which is to be expected. That's this first point here. And then x equal to 8 would be this point here. And so coming back to our questions all the way up, how long will the arrow be in the air or aloft? And that would be 8 seconds. So as you're working through this course, you can't forget about your algebra along the way and all that you've learned there as well. Finally, I think that wraps up 2.5. So I hope this is helpful as you work through the problems.